Okay, in this video, we're going to talk a little bit about signal paths and the process that we can expect when we encounter different types of audio systems in different kinds of settings. In particular, as music teachers in schools, we are all asked to troubleshoot or encounter multiple different kinds of audio and video setups. As usually that's part of what people are asked to do. And I would just like to address a few of those and basic patterns that most audio systems adhere to, and what we can expect in certain kinds of scenarios. So in this situation, I'm sorry, excuse me. I usually start showing students in an intro to music tech course this model, and we ask them to learn this model as an analog audio system, and we'll talk more about what analog and digital and all that sort of thing in the next video. But this path is one that everything typically follows, and once we start talking about digital audio, we can insert that digital realm into this model. So if we dwell on these four boxes, this is a staging up of signal. Our input transducer is a converter that changes acoustic energy, or the excitation of air molecules around us, into an electrical signal. And we talk about these energy realms from analog to electric, or from acoustic to electric. An analog audio system is one that recreates that waveform. That compression and rarefaction of air molecules into an analog electrical audio signal. So we have our input transducer, which is basically like a microphone or a pickup that then goes to our preamplifier. Our preamplifier takes that really small electrical signal and expands it to another type of signal called line level. That preamplifier then goes to a power amplifier, which makes it much more powerful so that it can be output by a speaker. And so these four stages are gradually changing or lifting up that signal, that original electrical signal. Your public address systems, your guitar amps, your hi-fi stereos, all of these sorts of things adhere to this model. Sometimes these are packaged in different ways, where maybe if it's a CD player, we're already at the line level point. If it's a microphone, we're at the input transducer point, sending out mic level. And so I have a few examples here to show us to help demonstrate these signal paths. Your basic microphone to mixer to powered monitor setup is one that encompasses that same model. We have our input transducer, our microphone. This is a dynamic microphone that is putting mic signal into this XLR cable here, right? We're going to plug that into our analog mixer at this point, okay? This is where the preamps are, and our mixer then will take it out of the output section to line level that will be sent to a monitor, okay? This monitor has two of those components in it. It has a power amp and a speaker in it. If you can plug in the speaker, that means it is a powered monitor, meaning that it has an amplifier in it. So on the back, you will see a volume setting and a power switch. These are very common, especially in schools, and they are what most folks have in their studios these days. Separate amps for passive speakers are generally not as common. Those are a little bit more, they're a lot of trouble because you have to match output with the actual speaker. In a powered monitor situation, these are engineered together, and so they work really well together. Most powered speakers like the JBL Eon series, or I'm blanking on other models. Those are large portable PA speakers for outdoor settings. Those are also powered, and they have their own amps built in. This is also an analog audio system, same microphone, same little mixer, but this one goes into a power amp and then into a passive speaker. And that is also adhering to the same model as we saw up here. The digital realm it uses the same basic input and output components, but we are now importing them into a digital realm. So we still have an input transducer that is taking acoustic phenomena and changing it into electricity. And that electrical signal is being sent to a preamplifier, but at some point we have to convert it into data. The digital realm is not electrical, it is a series of ones and zeros, and so we need to change that into data. That's what the digital audio interface does. It is a box that incorporates both your preamplifier and your digital audio converter, your analog to digital converter, changing it into a language that your computer can understand. We'll unpack this a little bit more in the next video. But in this example, we have a compact sort of studio setup where we have an audio interface, which has a preamp in it because we have XLR plugs here on the front. We can plug our guitar, we can plug our microphones, we can plug a keyboard synthesizer, any sort of thing into this interface. And this interface is meant to be half mixer, half digital audio converter. And so the inputs are going to be analog, but the output will be by USB or I have FireWire on here, but FireWire is becoming less and less of a thing. Mostly it's just USB. So a USB cable carries data to a computer, and your computer can then understand what's happening with the audio, and because it's been encoded. For a playback scenario, we have the reverse. We have a computer sending data to your digital audio interface that is being reconverted back into an electrical signal that is then boosted by an amplifier and then output to a speaker. And so in that case, your computer is sending data out of a USB cable to your interface, and then that is sending out audio to your powered monitor. So it's almost like this computer and interface are interrupting that original signal flow in a way that converts it to digital. And so that is something that it can understand. So your computer sending a signal to your digital audio interface. Digital audio interfaces could be big or small. Sometimes they're really tiny and they have maybe just one input. Sometimes they're really large and they have 16 inputs or 8. Well, 16 is pretty much crazy huge, but 8 inputs. Our electronic music studio downstairs has an 8 input digital audio interface, 8 in, 8 out. Our recording studio in Doudna actually has a different interface where it uses Ethernet, so it has an infinite amount of inputs. It's pretty insane. But it's all basically the same concept where you have some sort of conversion process happening between electric analog to digital audio. And then this sends analog audio to your speakers or headphones or whatever you're using. So every system uses this model. Sometimes it inserts the digital realm into the middle here, as you can see in these signal paths. We sometimes talk about smartphones in class. Smartphones incorporate the digital audio conversion process in a nanosecond. You have a microphone that is carrying your voice. That voice is being converted into a digital signal that is being sent or stored. When you hear people on your smartphone, you are hearing that digital conversion reconverted. So you're hearing a digital signal that is then sent through a DAC to a speaker or an earbud or whatever you're using. It's all the same process.